Hello students, welcome to Machine Design 1. We are in the second module. In the past videos, we have solved several problems using instantaneous center method and relative velocity method. Now also we are going to solve a problem using relative velocity method. This is a problem solved in the previous video. Um, here, here you can notice one thing. This is slider. For this slider, since it is traveling on the CD, we have drawn a parallel line for slider. Okay, we have drawn parallel line to CD. We have drawn a line which is parallel line to CD. At the same time, this CD link, CD is a CD is a oscillating lever, oscillating slaughter bar. CD is a oscillating slaughter bar. So for CD we have drawn a perpendicular line. For CD we have drawn a perpendicular line. We have drawn this perpendicular line here. Okay. So same link has been drawn for perpendicular. Same link has been taken as a reference line for drawing a perpendicular line. Also parallel line. Okay. So in this problem also we are going to see the similar thing in this problem also. Okay, here in this problem we have a trunion means, see this link EF, this link EF will oscillate like this, will oscillate front and back like this EF will oscillate like this, but in the middle of EF there is a point O. This point O is called as floating link. This point O is called as floating link, otherwise trunion, also called as trunion. Okay, point O or point Q. This point Q is on link EF. This point is called as trunion or floating link, because here we have a fixed link at this place. Here we have a fixed link O, so this point Q will rub this fixed link like this. This point cannot oscillate, instead this point will slide over fixed link O. Remaining part of the link will oscillate. Okay, same link, only one link. EF is the same link, but in the same link all the other place will oscillate, but this one place will not oscillate, instead it will slide over the fixed link O. So remember this, while drawing velocity diagram I will explain the rest of the things. Okay, remember this. First let us read the question. And we will draw the space diagram. So in the question they are given AD 650 mm, AB 100 mm, BC 800 mm, CD 250 mm, and rest of the things, and they are given BAD angle 135 degree, and speed of the crank AB is 300 rpm. We have to find out the velocity of the sliding link of link EF in trunion. Okay, that is a question. Right. First we have to draw space diagram. So this is a space diagram. Space diagram. So we have to scale it. We scale like 1 centimeter equal to, what is the length? 650 mm. So we will scale like this. 1 centimeter equal to 100 units. 1 centimeter equal to 100 units. Okay, we will scale like this. 1 centimeter equal to 100 unit. So if it is AD is 650 mm means you have to draw 6.5 centimeter. AD is 650 mm means you have to draw 6.5 centimeter. AB is 100 means you have to draw 1 centimeter. This is 800 means you have to draw 8 centimeter. This is 250 means you have to draw 2.5 centimeter. These all the three links B, E, C, E, F are 400 means you have to draw 4 centimeter. FO is 240 means you have to draw 2.4 centimeter. And FS is 400 mm means you have to draw 4 centimeter. Like that we have scaled it. Okay, if you draw like this means it will fit inside this. It will fit inside the drawing sheet. Okay. So first AD. Draw this horizontal line. Draw this horizontal line AD. Okay, draw this horizontal line AD 6.5 centimeter. Okay. After drawing this, BAD is 135 degree. BAD is 135 degree. So this angle is 135 degree. Keep your protector on point A. Keep your protector on point A. So from here 0 to 135. This line is 0. So like you have to go like this: 0, 10 degree, 20 degree, 30 degree, 40, 50, 60, 70, 80, 90, 110, 120, 130. So 130 degree. So 130 degree you have to draw AB. AB is 100 mm. 100 mm means 1 centimeter. So here draw 1 centimeter line. Here draw 1 centimeter line. Draw 1 centimeter line. Take your compass. Take your compass. BC length is 800 mm. That is 8 centimeter. Okay, we have scaled it like that. Actually 800 mm means 80 centimeter. But here we have scaled like 1 centimeter equal to 100 units. So 800 mm means, so we have here we have to draw 8 centimeter line. So in the compass take 8 centimeter, and keep one end of the compass on point B and draw curve. Draw the curve like this. Okay, draw the curve like this. Okay, and have the compass with you. And CD is 250, that is 2.5 centimeter. Take 2.5 centimeter on the compass, keep one end on D and another end cut the curve. So we got point C. We got point C. And BE. BE is BE, CE, EF. All are 400. Actually, total length of BC is 800. That is 8 centimeter. On middle of BC, that is BE, CE. Both are 4 centimeter. So BE or CE, that is middle. Mark E. 4 centimeter. Mark E. Okay. Mark E. Right. Now draw a line. Draw a line that is actually this is 400. Okay, so we have to draw 4 centimeter line. draw a vertical, draw a horizontal line. Draw a horizontal line that should be above this line. Distance between this reference line, that is distance between AD and this reference line is 4 centimeter. Distance between this reference line AD and this reference line is 4 centimeter. Like that you have to draw a horizontal line. Okay, at the height of 4 centimeter, draw a reference line. Draw a reference line. Okay, draw a reference line. After that, at the height of 3 centimeter from here, okay, 3 centimeter from here, draw horizontal line. Okay, and 4 centimeter from A, 4 centimeter from A, and on this reference line mark point Q. Okay, do you understand? This point Q is 3 centimeter from the ground, and 4 centimeter from point A. 3 centimeter from ground and 4 centimeter from point A. Okay, I have drawn this line. I have drawn this point Q. And EF is passing through point Q. And length is 4 centimeter. EF is passing through point Q and length is 4 centimeter. So we have drawn this line, and from here FS is also 4 centimeter. Take 4 centimeter on the compass. And keep the one point of compass on F and put an arc on S. Put an arc on this horizontal line. And that is S. So we have finished this space diagram. Now we have to draw the velocity diagram. We have to draw velocity diagram. Before that, they given the speed of AB. It is in the clockwise direction. Speed of AB is 300 rpm. So omega equal to 2 pi n by 60, and we can find omega. Okay, 300 means 2 into pi into 300 divided by 60. We will get omega value. So we need velocity of AB. Velocity of AB equal to omega into AB. So we will get VAB. So we will get VAB. VAB is omega, this omega AB, 2 pi n by 60, 2 into pi into, wait, I will show it here. So omega AB is equal to 2 into pi into n. N is 300 rpm. divided by 60. After getting this answer, we have to find out VAB. VAB means VB. We can tell VAB or VB. So omega AB into length of AB. Length of AB from the question. From the question, what is the length of AB? Length of AB is 100 mm. 100 mm means 0.1 meter. Okay, 100 mm means 0.1 meter. So find the answer, 0.1 meter. And now we can start drawing the velocity diagram. Okay, scale the velocity value. I hope you will get around. Wait, I will tell you the value. So omega value will be 31.7 radian per second. That is the omega value. Because 60 5 times we can cancel it. 2 into 5 10. 10 into 3.17 31.7. Okay. Now 31.7 into 0.1. 31.7 into 0.1, 3.17. 3.17 meter per second. So here scale it. While scaling it, we can scale like 1 centimeter equal to 1 meter per second. We can have that as it is. First fix all the fixed points. What are the fixed points? A is fixed point, D is fixed point, O is fixed point. And this guide also fixed point. So we will give name as T for this guide. Okay. So here we can include T also. So these are all fixed points. Okay. Now it is AB is rotating in the clockwise direction. So it is moving like in the upward direction. So draw a perpendicular line. Draw a perpendicular line to AB. So here I have drawn a perpendicular line to AB. Okay, this is a perpendicular line to AB by the length 3.17 centimeter. By the length 3.17 centimeter. So I got AB. Okay, from here draw perpendicular line to BC. Draw perpendicular line to BC. Perpendicular line on both sides. Okay, draw perpendicular line to BC on B. So this line has been drawn. Okay, after drawing this, from D draw perpendicular line to CD. If you draw perpendicular line means this line will go like this. So DC, BC, meeting point is C. First we have drawn perpendicular line to AB. Perpendicular line to AB, 3.17 centimeter. You have drawn this line 3.17 centimeter. After drawing this, from B to C, a perpendicular line. I have drawn perpendicular line like this. After drawing this line, I have drawn a perpendicular line to CD. I have drawn a perpendicular line to CD. From D I have drawn a perpendicular line. So that is meeting with BC on point D. Okay. So I have got A, D, O points, and then I have drawn perpendicular line to AB. AB line I got, BC line I got, CD line I got. Okay, wow. This point E, this point E is on the middle of BC, on the middle of BC. So here also point E will be on the middle of BC. Okay, wow. So from E, from E draw EF, from E draw EF, perpendicular line. Okay, wow. So draw EF, perpendicular line. At the same time, point Q, is in the beginning of the problem itself I told. Point Q is sliding on O. Point Q is sliding on O. If something is sliding means we have to draw parallel line. So for point Q, I am drawing a line from O, parallel line. So here I will get point Q. Already I have drawn a perpendicular line to EF. Already I have drawn a perpendicular line to EF like this. Already I have drawn perpendicular line to EF like this. Okay, this is EF line. But I don't know where F will be. So I have just extended this line. I don't know where F will be. But I know one thing, point Q is sliding on O. So I have to draw parallel line. If something is sliding means you have to draw parallel line. And this is meeting on EF line on Q. Okay. Okay, Q is over. Now I got EQ. Okay. EQ is on line EF. So I know the length of EF. Measure from space diagram this length. Also I know EQ line. Similarly here also from velocity diagram EF EQ. From space diagram measure this EF length, E to F, this length. From space diagram mention it. Don't write it from the question. From the space diagram measure EF length and write it here. From space diagram measure EQ, this length, and write it here. From velocity diagram measure EQ length. Measure EQ length and write it here. Now the length which is unknown is EF. You can find it. You know all the EF, EQ, this length. Okay. Now you will find, if you calculate means you can get EF length and draw EF and draw the EF here. You got EF length and draw it here. Now FS, draw perpendicular line to FS. Draw perpendicular line to FS. I have drawn this line here. At the same time, finally slider. Slider S is sliding on the fixed link. Where is fixed link? This is fixed link. So draw a parallel line for slider. Now extend this line. So we got point D. Now what is the question? Now what is the, erase the remaining lines. Erase the remaining lines. Now what is the question? We'll go to question. Question is, we have to find out the velocity of sliding link of EF. Remember that sliding link of EF. What is the sliding link? Q is the sliding link. Yeah, sliding link of EF. What is the sliding link? Q is the sliding link. Now we will go to the answer. So what is the sliding link? This is the sliding link. OQ. 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 Here OQ. OQ is the sliding link. So here OQ. This is OQ. Now measure this distance from O to Q. Measure this distance and write the answer. That is the answer. Okay, va? Measure the distance and write it here. Meter per second. What is the scale? I think scale is 1 centimeter equal to 1 meter per second. So after measuring the distance, you can keep the answer as it is. We don't want to multiply with anything because the scale is 1 only. So find the answer and multiply it with 1 and write it here. Measure the distance. Measure distance OQ and write it here. That's all. Problem over. Okay. So watch the video carefully and solve the problem. In the next video, we will try to solve a problem from acceleration diagram.